Hello and welcome to the Creation Kit scripting series Papyrus tutorials. This is the 7th part of the series and the second part of the recursion, function recursions segment, excuse me. And in this recursive function segment we're going to look at how to formulate base cases. I'm going to preface this by saying this is not going to be your end-all solution for finding out how to do base cases. I'm going to just go over a few more examples and kind of discuss the process of finding base cases, but ultimately it will be something that you have to formulate on your own in the end. Okay, so what are base cases? They are special cases for return values or function operations that are limited, based on a limited value, excuse me. So the example of operation based on a limiting value, die player die, whenever we did that function, we always check to see if the player was dead before calling the next iteration. And the player's death state became the recursive base case. Factorial, we kept going until we reached the value of 0 and then returned 1 in the end. Fibonacci, we kept going until we reached a fib of 0 or a fib of 1 in the divided calls. Because each time we call it recursively, it creates one function, two function, and those functions might create more functions. That's why I said until we reach the fib 0 or fib 1 in the various calls. We're going to see an example of both Fibonacci and factorial mapped out soon, later in these slides. So how do you create a base case? You have to check mathematically what the base case or ending case is. So general strategy I would do, since you're probably not going to do what computer scientists or higher level mathematicians do and use induction and prove that it's A, the base cases, and B, what the iteration process is. So first, map out your function on paper or in your favorite note-taking software that you have. Second, write out each step of your function. For example, you have factorial of 4, write what that does, because it's going to be 4 times factorial of 3, then write the next step, which would be 3 times factorial 2, and keep on doing that. Third, after the end of this process, determine if the function terminates. If it doesn't terminate, then you need to find out what's going on and find a termination point. Because the termination point is going to be your base case, or your base cases, depending on the function that you're doing. So let's look at mapped out for factorial. So I have arrows for both directions for the calls going down, and then once you get to the base case, the calls going back up. So factorial of 4, it will go down to 4 times the factorial of 3, then it will go over to 4 times 3 times factorial 2. It'll do the same thing with the factorial 1, factorial 0, and then at the very end. And then each of those, because the 1 at the very end of the 4 times 3 times 2 times 1 times 1, it goes back up, so 1's replaced where the factorial of 0's at, 1's replaced where the factorial of 1's at, the factorial of 2, it's going to be 2 times the result of the previous, and so on and so forth until you get 24 as the factorial of 4. Okay, now Fibonacci. Notice how it's different and how it branches down. So fib of 3, it divides into the fib of 2 and fib of 1. Fib of 1 only returns 1 because that's a base case. Fib of 2, however, splits into the fib of 1 and fib of 0, and both of those hit the base cases. The bigger that you have for the input value for Fibonacci, the more of these branches you'll have, but each branch will eventually reach either a 1 or a 0. or both 1 and 0. Okay, so let's look at a few new examples of recursion that can help us with formulating base cases. So multiplication is an operation that you can do without using the multiplication symbol, and instead you keep adding the value recursively. So 5 times 5, you just add 5 times. 5 plus 5 is 10, add another 5, that's 15, add another 5, that's 20, and then you add the last 5, and that's 25, which that's the answer of 5 times 5. Another example, 10 times 4, you add 10 4 times and you get 40. That's the right answer. So the base case here is when your second input into your function becomes 0. Because on each call of multiplication, you're going to have your basic value and then the number of times to add it. And then you keep decreasing the number of times to add as you go through the calls. Okay. And now then, it is possible to also do division by subtraction in our second example here. So you want to subtract your larger number by the smaller number and keep track of the number of times that you can do this evenly. So let's take an example, 20 divided by 4. You keep subtracting 4. It's 5 times that you can subtract it, so your answer is going to be 5 groups of 4 or 5. There's quite a few more base cases here because division's a more complicated operation. We're only going to look at integer division. We're not going to go into division of decimals or anything like that for this example because that's going to take a lot more legwork for formulating the base cases. So if your second input is 0, return 0. You can't divide by 0. That's something that you just can't do. It won't be a technically correct result, but that's how we're going to handle it in this case. If subtraction of both inputs is 0, you want to return 1. That makes sense. Like, whenever you get to the final 4 minus 4, that's going to be 0, so you want to return 1. Yes, it can subtract evenly. Okay, if your first input is less than your second input, i.e., let's say you have 5 divided by 10, that's going to return 0 because you can't divide that evenly. And since it's integer division, there is no remainder. Okay, now let's practice recursion, some more recursion. By adding the functions that we just talked about for multiplication and division. So, the same cell, I removed the script from the last episode and replaced it with a recursion BaseCases script. It's going to only have an event on init, and let's do our first recursion problem, multiplication. So debug.messageBox, we're going to just set them up here. So let's do our 5 times 5 equals, and then we're going to have and that's going to be the call for that one. Let's also put in our other example of 10 times 4 equals, and then we're going to add, multiply by add, then 10 as the first value and 4 for the next. So let's do a second recursion problem, and this is going to be division here. And we're going to do 20 divided by 4 equals, then we're going to add, divide by subtract. And we're going to have 20 and 4 there. And let's do a simple one just to illustrate base cases. Divide by subtract 5 and 5. Okay, so let's start off with multiplication here. First number to add, second number to keep track of number of times to add. Purpose of this function is to recreate multiplication via addition. Example, we're going to use 5 times 5 is going to equal 5 plus 5 plus 5 plus 5 plus 5. Okay. So int function multiply by add is what we called it. And then we're going to give it num, and then let's call it num to add, and int num times to add. Let's do our base case. Base case if num times to add is 0. Turn num to add let's map this out really quick. So we want to return num to add plus, and then the multiply by add num to add and num times to add minus 1. Let's put this in parentheses just so. Alright, so it's going to do the first call, num to add. It's going to add 5, and then it has to call it 4 more times. That's what we're giving it. So it's going to add again. Okay. I believe 2 will give us the right, instead of 1, the right answer there. First number to subtract second number to subtract. Purpose of this function is to recreate integer division via subtraction. Example, 20 divided by 4 will divide 5 times. Subtract 5 times, excuse me. So, int function divide by subtract, and we're going to have int num, and then int divide by. So let's look at our base cases real quick. So if the second input is 0, return 0. So base case number 1, if divide by is 0. Divide by 0, return 0. Base case number 2, if divide by, no, that's not right. If num minus divide by is 0, so if num minus divide by equal to 0, return 1. Let's do our base case number 3. If num is less than divide by. If num is less than divide by, return 0. Else, other valid cases. Return, and then we want to have 1 plus, and then the next call to divide by, which is going to be, we're going to have 2 parentheses here, num minus divide by, then divide by. And that should be our division function based off the base cases that we have listed here in the PowerPoints. Let's put this guy in parentheses just so Papyrus doesn't get confused out of its mind, potentially. Okay. So let's go here. See if it compiles. I missed an if somewhere. Yep, I missed 2 ifs actually. Because I was so focused on the getting the recursion right. So missing another if? Oh. That would be important, that we didn't have else ifs there. Okay. Now it should compile. Alright. Hypothetically this will work. There might be a little bit of flaw with multiplication. We'll find out in a moment, and we might have to come back to the creation kit if that is the case. I will see everybody in game though to test it out. Alright, we are in game, potentially for the only time, hopefully the only time. Let's see how the multiplication and division functions work. 5 times 5 is 25. 10 times 4 is 40. Okay, so less than 2 is correct. If we did less than 1, it would have returned a case too many. 5 divided by 5 is 1. Correct. 20 divided by 4 is 5. Beautiful. Those recursive functions worked on the first time. With recursion, you typically have to iterate more than we just did. But it worked the first time beautifully. And I will go back to the episode now to conclude this video. And we're back. If you have any questions over formulating base cases. I know I covered only a few examples and a general strategy on how to approach it, but I can try to help you with base cases in the future if needed, although it will take a lot of legwork on your part, I'm not going to lie. But methods to contact me, I have a Nexus profile, a forum, and otherwise. I will have those in the description as well as supplementary links to the content we discussed today. I'll have a little annotation as well on here. Feel free to message me on YouTube as well. And if you have questions about any of the past content, potential future content, scripting questions in general, or scripting requests, feel free to message me. Until then, I will see you on the next episode.